everybody. We are starting on a new section today, and we are going to be multiplying radicals. This section is going to be shorter than our simplifying radicals section because we've done a little bit of multiplying radicals beforehand when we were simplifying it. Now it's kind of adding on those extra two sections of using distributive property as well as using FOIL. Okay, so let's look at our multiplying radicals rule. When we multiply radicals, our first step is to multiply our coefficients. That makes this similar to when we add and subtract radicals. Remember, when we add and subtract radicals, we're only messing with our coefficients if our radicand is the same. Here, it does not matter what our radicand is. It can be different. So when you multiply radicals, your first step is to multiply your coefficients. Then you are going to multiply your radicands using the product rule. If you had the square root of A multiplied by the square root of B, that's equal to the square root of A times B. So it's kind of taking that junk and putting it in the trunk. Then finally, after you multiply your radicands, you're going to simplify what's left. So let's look at some examples. If I have the square root of 3 multiplied by the square root of 2, my coefficients are 1 and 1. 1 multiplied by 1 gives me 1. Now I'm going to multiply my radicand. So square root 3 times square root 2. So 3 times 2 gives me 6. So my answer is the square root of 6. Okay, let's look at example 2. If I did have a higher value for my coefficient, I have 2 square root 8 multiplied by negative 3 square root 2. I'm going to multiply my coefficient. So 2 times negative 3 gives me negative 6. Then I multiply my radicand. So 8 multiplied by 2 gives me square root of 16. I have negative 6 square root 16. Can that simplify down further? Yeah, I can. The square root of 16 simplifies down to 4, and we get rid of that radicand. So now this becomes negative 6 times 4, which equals negative 24. Okay, so that's the basic process for multiplying radicals. Let's look at some examples, and then we'll finally get into distributive property and FOIL. All right, example 3. I have 5 square root 10 multiplied by negative 7 square root 12. When I multiply radicals, I first multiply my coefficient, then I multiply my junk in my trunk. So 5 times negative 7, my coefficients gives me negative 35. Then I'm going to multiply my radicand. So 10 times 12 gives me 120. I am not done there. I need to simplify my radicand. My coefficient's okay, but I need to simplify my radicand. Is 120 a perfect square? No, it's not. So we cannot just simply plug that into your calculator and get a whole number. I need to break that up. So I'm going to rewrite this as negative 35 multiplied by 120. Oh, nope, square root of 120. Kind of show that they're not conjoined at the hip. And then I'm going to make my list. I could go through my list and go, okay, 120 divided by 1, 120 divided by 2, 120 divided by 3. But let me tell you, we'd be here all day because that's a large number. So my tip for you is to go to that list of those perfect squares and check and see, are those divisible by 120? So obviously 1 and 120 would be multiples of 120. 120 divided by 4 gives me 30, okay? And that's about as high as I can go as looking at multiples that have a perfect square. I have 4. So I'm going to break up 120 divided by, or multiplied by square root 4 multiplied by square root 30. I could spend all day going through more multiples with you, but I don't think you guys want to watch a hour-long lecture video. Okay? But that's how the process goes. It's a little bit of guessing and checking to see what perfect squares are divisible by that number. All right, time to simplify. looking at those radicals, my perfect square of 4, that simplifies down to 2. So I have negative 35 times 2 times square root 30. Can square root 30 be simplified at all? Because 30 is kind of a big number. Well, let's look at my list. Okay, what's divisible by 30? That breaks up into 1 and 30, 2 and 15, 3 and 10, 5 and 6. Are any of those perfect squares besides 1? No, none of those are. So square root 30 is as simple as we can go. So now my last step is to simplify those coefficients. So negative 35 times 2 gives me, isn't that 70, right? Yeah, 70. So I have negative 70 square root 30 as my final answer. Okay, let's look at another example. I have negative 5 square root 20x multiplied by 3 square root 15x. What's my process for multiplying radicals? Well, first I multiply my coefficient, then I multiply my radicands, and then finally I simplify. So we're going to do that process. So negative 5 times 3 gives me negative 15. 20 multiplied by 15 gives me 300. And x times x gives me x squared. Think back to our properties of radicals in order to simplify it. This equation we have here, or this stuff we have left, that can be expanded out to negative 15 multiplied by square root of 300 multiplied by square root of x squared. Okay, I like to break it up so I can simplify its components in order to rejoin it at the end. Because sometimes when you look at the big picture together, you make your mistakes. So I like to break it up. Okay, negative 15 stays the same. Okay, but square root 300, we got to break that up. Now, one thing that sticks out to me is that 300 is divisible by 100. And 100 is a perfect square. 300, that breaks up into square root of 100 multiplied by square root of 3, because 100 times 3 gives me 300. Then I can simplify that further. But before we look further at that one, let's look over at our x squared. All right, remember, when I have a variable within my radical, if it's even, I'm going to divide by 2 and get rid of my radical. So 2 divided by 2 gives me 1, and get rid of my radical, I would just be left with x. So now we simplified our variable. Okay, let's go back to our the rest of our problem. So negative 15 drops down. The square root of 100 is 10. And then finally, I just bring down square root 3 and x. So my last job is to swing my variable over here and multiply my coefficients. So negative 15 times 10 gives me negative 150 with my variable square root of 3. Right? So my final answer is negative 150x square root 3. Okay. I actually enjoy these problems. I find it fun. All right. Another example before we look at distributive property. Here, what's extremely important is order of operations. PEMDAS. Remember PEMDAS. Parentheses, exponents, multiplication, division, and addition and subtraction. So you need to multiply first before we subtract. All right. I have 10 square root 2 multiplied by 3 square root 10 minus 6 square root 5. My first job is going to be to combine these in order to subtract. All right, coefficients first. 10 times 3 gives me 30. Square root 2 times square root 10 gives me the square root of 20. Oh my goodness, minus 6 square root 5 Can I subtract that right there, right now? No, I can't because I don't have the same radicand. I have to have the same radicand in order to combine. So my job here is going to be able to simplify that 20 in order to where I have a radicand that has a square root 5 or a radicand that has a 5. So I'm going to break up my square root 20 into square root of 4 multiplied by square root of 5. Now that I have that, I can simplify that 4, and I will have the same radicand. I will have square root 5. All right. Square root of 4 simplifies down to 2. 30 times 2 is 60. So I have 60 square root 5 minus 6 square root 5. When I subtract, I leave my junk in my trunk, and I only mess with my coefficients. So 60 minus 6 gives me 54 square root 5 as my final answer. I apologize for that screen glitching. It happens whenever I touch the iPad. I'll try not to. All right, now that we have the basic process down, let's look at the use of multiplying radicals within distributive property. We complete the same process as we would with whole numbers when using the distributive property. So when I use the distributive property, I multiply my outside component by each component within the parentheses. So if I have square root 6 multiplied by 3 plus square root 8, I'm going to multiply square root 6 by 3. So my answer is 3 square root 6. Why would I not multiply that 3 by the 6? Well, 3 is a coefficient. And my square root 6 is a radicand, so I do not combine them. I only attach my 3 to the front of my radical. I multiply it by my quote-unquote coefficient because I haven't understood 1 in front of here. Now I multiply square root 6 by square root 8, or I multiply my junk in my trunk. So I have square root of 48. Then for my final step would be to simplify that square root 48. So what does the square root of 48 simplify out to? So I'm going to write my list for 48. And I'm just going to think, okay, what numbers are my perfect squares that are divisible by 48? 48 divided by 1 is 48. 4 and 12. 16 and 3. Let's see. 8 and 6 do go into 48. However, neither of those are perfect squares. But 16 looks like a high enough number that works for me. So, time to break that up. So, I have 3 square root 6, which breaks up into square root of 16 multiplied by square root of 3. Now that I have 3 and square root 6, plus square root 16 times 3, I'm going to simplify down that 16 to give me my final answer of 3 square root 6 plus 4 square root 3. There we go. Woohoo! We did it. Our last problem for distributive property is to FOIL. And just like distributive property, we've used the same process as before. So I'm going to use first, outside, inside, and last. All right. First, 4 times 2 gives me 8. Outside, 4 times negative square root 3 gives me negative 4 square root 3. Inside is going to be square root 2 times 2, which gives me 2 square root 3. And then for my last is going to be square root 3 times negative square root 3. So that gives me negative square root 9. So you cannot drop that negative sign there. Be careful. Now that I have that, it's about simplifying. So my 8 drops down. I combine my like terms because those have the same radicand. So 2 minus 4 gives me negative 2 square root 3. And then finally, the square root of 9 is 3. So it gives me 3. 8 minus 3 is 5. So my final answer is 5 minus 2 square root 3. All right, that's all I have for you today. As always, if you have any questions, please let me know.